Hello everybody, today I'm going to be talking to you guys about the life cycle of a star. Let's start. So before anything, what's a star? Star is, just look out at your window. It's the bright ball thing. That's the sun, and it's a star. And there are billions of stars in our galaxy, the Milky Way galaxy. Okay, so before anything happens, there is the nebula. You can also memorize it as the interstellar nebula. So the nebula is basically a cloud of dust and gas. It's like this, right? It's just a cloud of dust and gas floating in space. And eventually, the centrifugal force of gravity pulls it inward, right? Pulls the cloud of dust and gas inward, and it becomes sort of a ball, right? Ball of energy. Where is the energy coming from? So a cloud of dust and gas, they contain hydrogen atoms, and because of the inward gravitational force, the hydrogen atoms fuse together in a process called nuclear fusion, right? So the nuclear fusion causes these hydrogen atoms to fuse and form helium atoms. This provides the energy of the star, which gives out and exerts a sort of pressure, right? So this stage is called a protostar. So nebula gets pulled inward by gravity and becomes protostar. It's not yet stable. So as time goes on, the inward force that pulls the star together becomes equal to the outward pressure exerted by the energy of the star. And when these two things become equal, the pressure exerted and the inward force become equal, this is now known as a stable star. It's not round, but you get the idea. So a stable star, that's the stage our sun is at right now, when it's equal, right? The outward pressure is equal to the inward gravitational force. And eventually, like all good things come to an end, the stable star becomes a red giant. So before anything, it depends on the size of the star, whether it's going to be a red giant or a red supergiant. So let's say for this example, we're using a small average star. So the star becomes a red giant. And essentially what it means is the gravitational force is no longer there, and the helium atoms just grow. The pressure becomes more, and so it becomes bigger. It becomes a red giant. And the red giant also eventually runs out of helium atoms, hydrogen atoms, and it becomes a white dwarf, right? It becomes a white dwarf, or it explodes and becomes a planetary nebula. It's a cycle. It becomes a planetary nebula, but with a white dwarf at its center, in the middle of it. So a planetary nebula, just like how it started. So now let's use another example. Let's say this is a larger star with a larger mass. Because it is larger, it becomes a red supergiant. And the red supergiant can become two things. It can either become a black hole. Black hole is essentially a void in space and time where even light cannot enter. That is why there is a ring of light around it. The light bends around the black hole. If you see Interstellar, you know that. So yeah, it becomes a black hole. And what's the other thing that it can become? So, oh wait, my bad. So it becomes the red supergiant does not become a black hole yet. It becomes a supernova first. It explodes as a supernova. In the 1800s, there was a bright thing in the sky. You can even see it at night. People were wondering if that's a new star being formed. But the truth was, it was the end of a star. When the star exploded in a big, bright explosion, which is called a supernova. And the supernova can eventually become a neutron star, a small neutron star, or it can become a black hole, refer to what I said before. So let's review this entire thing again. First, there is a interstellar nebula of cloud and gas. The inward gravity pulls and it becomes a protostar, and the energy given out by the protostar becomes equal with the inward gravity. It becomes a stable star, and the stable star eventually runs out and it becomes either a red supergiant, or a red giant. The red supergiant can become a black hole, or a red supergiant can explode into a supernova and become a black hole or a neutron star. And the red giant can become a white dwarf or a planetary nebula with the white dwarf at its center. So that's it. That's it for the life cycle of a star. Right. I'll give you 25 push-ups. Let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Come on. 1, 2, 3, 4, 5. Whoa! I just woke up before this. I'm a little tired. So, thank you guys for watching. If you have any questions, leave it in the comments below.